Hi, this is Marshall from Scree Custom Keyboards. I run Scree LLC and make custom keyboards. Now, a lot of that's not interesting to you guys, but I make all my keyboards in-house, including PCBs of a variety of different designs, shapes. I make microcontrollers and flexible ribbon cables and screen mounts and all kinds of other cool stuff. Okay. Um, And I've been doing this for 3 years, and I've used Openpnp that whole time. I'm going to try and keep this concise, quick, and easy. Um, the old way would be to, let's see, it's open. So I have Openpnp running on, this is just my editing and work machine. This isn't where my machines are. But swap scenes. There we go. Hi, and now I'm in the corner. Okay. So the traditional way to do this would be you got to go to like a package and you make a package ID and then you make like a part and then you tie it to that. Or what I would do is I would use Open or Easy EDA. I know KiCad's there too. KiCad has footprint problems too, so like it's not immune to these problems. But like I would take this and like I would export pick and place file and then import that pick and place file into OpenPNP, and then like it'll make the part. You can tell it to make the parts or not. If you have it make the parts, then you got to go through and you got to like set the packages. So you got to go. Let's see. We'll put this here. On here, and then I don't want that. I want that. Okay, so then you would like, boy, you say that this is such an easy program. It is not. So like you would have to go get the footprint data, and you can get the footprint data from here. Like I could go library. I could look up this component. Like if I was doing this component, let's say, um, I could go into it and then I would have to manually add, where's the footprint tab? So I'd have to add the number of pads and I'd have to put their coordinate values and all this stupid things. And this takes, when you add it all together, hours. Now, if you got a really simple board, it's not so bad. Or if you reuse only precisely the same components, it's not so bad. But I find that annoying. And I've been getting more and more complex. So with the increased complexity and the new components and stuff, I'm hoping. Hold on. I don't know why it's not centering. Whee! There. I'm hoping. Well, that didn't work very well either. I'm hoping to make this process easier. So for the last couple of days, weeks, probably, this has been a long time coming. I've been trying to reimagine a system that makes this easy. So I've been working. I don't have a whole lot of coding experience, so I've been working with Claude Code. Um, but I do have a whole lot of OpenPnP experience, Easy EDA, and LCSC experience. So I've been hoping to make a functional program. To that end, I have made a program. I don't have it launched. Oh no. Hold on. So we go here, run. This opens. Hey. So I've made this program, and this program has some core fundamentals. It's going to jack into OpenPnP. It's going to interact with your packages and parts.xml files, but doing that, it has a lot of safeguards. So I have a create backup button. You can navigate to your backups. You can restore backups. It's got, when it's doing writing, it's in a lockstep manner so that it can't override things. It should be fine. And in my testing experience, it is. It has the ability to browse. So like you navigate to your OpenPnP repository or folder. If you've got it in a different place, that's why there's a browse function. And then you import a BOM. So let's explain this a little better. In here, I have this PCB design. this PCB design is this PCB. And I have this PCB panelized, but we'll not get into that just yet. So I just go here, BOM, and I need to have name, I need to have footprint, I need to have designator, and I need to have the supplier part, which is the LCSC number. So if you were doing this with KiCad and you had all the LCSC footprints and you wanted to use those, that you just give it the LCSC number and it'll figure it out. So I export that, which is what I have here. Open. So here is that. And hold on, I've got to, well, one, we have to make sure Openpnp cannot be running while the program's running. So I close that. I'm going to restore to a very old backup. This backup only has the fiducials in it, fiducial footprint and packages. Ooh, yeah, it's supposed to reboot. Okay. So, oh no, why is Windows? Did I freeze or did Explorer freeze? That should not have happened. Hey, isn't Windows 11 the most amazing program ever? What is this? My start bar is broken. There we go. Okay. I'm gonna redo this. I think the start bar just like had a hiccup. Yeah, there's what I'm supposed to see. Okay. Why did that happen? Oh, it might be because it's restoring. Boy, this was supposed to be a quick video, and now I'm running into trouble. Hold on. So there. Why is that happening? Here. Yeah. Okay. If there's a bug, I will fix it before I release it. All right. So we've restored. We're gonna load a bomb. We're gonna go to downloads. The bomb temp. Nope, that's not helpful. Go to downloads. We're gonna go to this one. Okay. So it has the option to export a bomb template. You can just save that wherever. That'll have just the categories it wants, but doing it this way works too. So it's loaded that. Now, when I click the Analyze button, it's going to parse the components. It's going to do two things. It's going to make a theoretical, oh, hold on. Whoa. Yeah. Yeah. Okay. It's going to make a theoretical part name. So whenever you make a part in Openpnp, it has first the footprint, so C0402, and then it has the minus symbol or the kebab, and then it'll have the value or the name, and that becomes your total part name. It does that anytime I import within pick and place file too. So there's that. It's going to make that, and then it's going to parse. It's going to go through this, which is the bomb. It's going to find the unique ones. So like it knows C2, C3, and C5 are all this. So it doesn't make one for each. It knows that this is a unique component. So it makes the unique components. Then it cross-references that with your parts.xml file. It goes through and reads all of them. So it does this, and then it tells me, and it does this also for footprints. So like it knows a C0402 is a footprint in of itself. So it says it needs to create 21 footprints, and it needs to create 31 parts. And it's skipping one because I have here, we will look. Here, I have U6, which is just a custom programmer header that I've made. So it has no LCSC now. Now I can click Start Processing. And what it does is, what this program does is it's a parser. So it reads the XML files and it reads bombs, and then it pulls data based on the LCSC part number. So we have this part number column. And it will go to lcsc.com, load the specific part, and then lcsc.com has that little pop-up that'll show you what the footprint is. Well, within that is the data necessary to make a footprint. And that's what I have the program doing. So it will now generate a footprint, this, with the correct coordinates and values, like the size and that, for the part or for the footprint, and then it'll connect that to the part. And then it'll also make the part in your OpenPnP library too. So I'm going to go through these really quick. The big thing is so I got to do 21 of these. You have the ability to set the height. The reason why it's not auto setting the height is because LCSC doesn't really provide this information. It's generally tucked away in the BOM, or not in the BOM, in the data sheet. So if I have it generate this button, so you can click this and it'll open up a new tab, and then you can click on this to open up the BOM or the data sheet, and then you can scroll through here. Like it'll tell you the T value here for the height for like 0402 T is 0.5 millimeters. I use 0.3. That's just because I want a little bit of squish. But so I set this, I make sure this is right. For the nozzle tip, it knows a bunch of standard sizes like STO 23 and so on and so forth. And it has a sort of logic based on the CN size nozzles as to which nozzle should be used where. So it'll auto select, but you can click this and you can set it yourself. So I'm just going to chew through these real quick. And then, well, actually, how about this? We don't even set all firm. Well, hold on, 5.2. I'm going to do all of them. That way, it's a complete process and you can see that it all works. I know this is 21 of these and it's going to take a little bit of time, but if you've ever done this, you know how long this takes. Like loading up each footprint size and either using the wizard that generates it or doing it by hand takes a long time. It's in no way, shape, or form quick, especially when you realize I'm 57% of the way through the 20 parts I have to do already. And the reason why I'm that fast is because I can look at this. I know this is what the part should look like. I know what the part is, but if you've made your PCB, you have an understanding of what the parts are. But I can always click here. If I want to go, I'm not so sure if this is right. I click Easy EDA. Hey, that footprint looks right. The only thing it doesn't have is the cutout corner, and that's okay. It's not going to have that cutout corner because you can't do that in OpenPnP no matter what. Like you only make rectangles or rounded rectangles. Set this to 3. So really, this came about mostly because I'm tired of doing this all myself. I've been getting more elaborate boards, and I've been using completely new footprints. And I'm running into problems of, well, I might not have set the footprint right the first time, or other problems. Hey, look at this. We're almost done. So on this last one, which is a USB socket, I hate where the origin of the USB socket is, but that's another story. I'm going to do this wrong so that you can see that even if you do it wrong, you can still fix it. So I'm going to say this is 444 millimeters above the board. That's not possible. And we're going to set this to a CN 140, which I don't normally use for that part. So once you've completed and it's done, it's going to pop up this window. And this is the important window. This is when it writes to the XML database. So when we press this, it writes. And it tells you it's written. I need to change this. It's not restart. You don't want OpenPnP ever running when this program is running. Because when you close OpenPnP, it's going to rewrite the XML files from its cache. And that like obliterates all your work. So you don't want to do that. All right, so we've done that, but we made a problem. So here, I can browse through, and when I click on these, it pulls up the footprint. If I want to change something, I have this bottom section that has values, so you can change these. So I do want to change these, because I set the USB wrong. USB is not this tall. The USB is like 3.2 with some squish. And I want to use the CN220. I press apply changes to selected, and it tells you you've updated this. So that updates the data in this table. And then you have to click write to Openpnp. So then it gives you a summary of what's been done. There have been 21 packages added with 31 parts. And the reason why there's more parts is like I have a bunch of C0402 components, which is 0402 size capacitors. I have like a 1 UF. I have 100 NF. I have a bunch of these. And that's where that comes from. Okay, so that's done. The program's done its job. I can minimize or close it. And then I'm going to open Openpnp. And let's see what we have. Now, again, this machine is not the machine that runs Openpnp, so I can't like turn it on and interact with it. But what it did do is originally this only had these. All of these and all of these are generated by my program. And then we can check the packages. So let's look at a C0402. We can look at footprints. And it has footprint values. If I want to see it visualized, I can do that too. So there's my footprint. If I want to see this one, you got to click and drag because when it's not running, it doesn't auto-update. These. Let's see. Where's a more complicated one? Let's look at this silly USB one. Oh, maybe when you zoom, it auto-updates. Hey, it updates when you zoom. I don't know why. Sometimes Openpnp has some bad behavior too. So here's a complicated one. This one absolutely has polarity. So let's see. I think I have that one open here. Yeah. So this is Texas Instruments. It's a single cell lithium ion charger. It's a really nice, well-designed one. Okay. So we have a fiducial marking or a silkscreen marking here, and there's pin 1. I want to make sure that pin 1's where it's supposed to be. Well, Marshall, it does. Now, normally, what I like to do is I like to go set my pin 1s to like 50%, or not rotation. Hold on. Oh gosh, we're going to break it. 50% roundness. And then we'll update this. And hey, there's that. And you'll notice it's in the top left quadrant of the component, which lines up with this. And here. Yeah, right there. So top left quadrant. So it is when it parses it, it's parsing for the pad order, and then it is putting the correct width, length, X and Y positioning based on that pad. So it's not garbling anything or anything like that. It seems to handle everything I've shoved at it. It does a darn good job. I'm very happy with it, basically. And that took me, what, 4 minutes, 3 minutes to go through that. If you've got a more complex board, it takes longer. But the other important thing is these parts are named correctly. So these names correspond with the pick and place file that I would import. So when you go and you make a job and then you go file, import placements. I think it'll also work the same way with KiCad. And right now it only works with LCSC files, but I can see if I can parse from other places. I think that covers everything. Currently, it's a very, very beta program. I have some things to improve. I would like to have this ran by someone with a Mac and someone with a Linux machine to see what breaks, because I don't know. I'm not a professional coder by any sense. If Claude Code didn't exist, this would have taken me probably years, or more likely I would have just given up. But with Claude Code helping along the way, I've been able to make this turn out fantastic. So let's see. I think that covers most everything. If you're interested in trying the program, please reach out to me. You can get a hold of me on YouTube. On Discord, you can find me by whispering hashtag ALAKUU. You can email me at big, B-I-G, scree, S-K-R-E-E, at gmail.com. Or you can just submit a contact form through my website, which is www.skree.us. And I'm going to have a GitHub repository for this. I'm not sure if I'm wanting to just provide the original Python files and stuff like that. I've managed to get it rolled into a single portable exe file that should just run. But again, it needs to be tested more. I have a variety of Windows machines on a variety of different processors and configurations. But integration hell is integration hell. This very well could cause problems on other systems or other environments. I have bigger plans. So like I showed this, but these are my LED strips. They're custom spaced. For a little bit more background, I have a Panda placer. So it uses the bamboo feeders like this one. This is a really old one. They support up to 24 millimeter tape, but they're not sprocket driven and they don't have any kind of optical feedback. So I'm in the process of designing my own feeders. They're going to be aluminum PCBs. They're going to work fantastic, hopefully. I'm going to show a little bit that at the end. If all you're interested in was that little bit about the program, then you can head off. I don't mean to keep you here. I realize this video is 21 minutes long. Sorry. But if you want to stick around and see the ecosystem I'm hoping to create and mostly provide to people, I'll show off some of that now. These are meant to work on a rack that has slots. So on these is going to be a QR code, one on the back, one on the front. It's actually going to be likely a data matrix rectangle for higher data density. Like on the 8 millimeter wide feeders, which are technically 12 millimeters wide, I can only have a 12 by 12 millimeter QR code, which doesn't hold a lot of data. And if you've seen some of the auto-generated footprints or part names, they're huge. They're like 60, 70 characters long. So I need to deal with that. And the only way I can deal with that is with a bigger QR code. But I've been demoing the idea. I have QR codes sheets that I cut and stick. I can get OCR to work mostly for that, but I have some camera issues. I've been offloading that to a local OCR that works a lot better. But I'm redesigning these feeders. But either way, I'm keeping my redesign inside this envelope, so it will still fit and work with the design architecture. The nice thing about these is they have feeder slots, and this feeder doesn't have a unique ID. It just goes, whatever I'm plugged into, I feed. So Openpnp goes bank 1, feeder 6, feed forward 4 millimeters 3 times, or something like that. And then this one, which would be in that slot, would feed. But if a different feeder was in it, it would also feed. Or not also, that one would feed, and not this one being that. Whereas I've seen a lot of designs where they're like using wireless, and I think the slots are the more important thing than because OpenPNP, the big thing is knowing where that part is in coordinate space in relativity to the XY origin. So if this has its unique ID and it moves around, then it's really hard to say, hey, I'm actually in this slot. So I'm doing the slots are the dominant indicator. But either way, so this will have a QR code on it and it'll have some component. I'll be able to take my phone, scan the QR code, and then send that QR code to my web storage server, which will say, there's an open slot for this feeder. Store it here. And it'll light up on this strip. These break off and they get longer and longer. This just was the more economic way of doing it. Um, it'll light up with a slot, and then I just store it. I press confirm, and then next time I need to pull feeders and I tell it what parts I need, it knows where to pull it from. The web server also can ingest the .board files. So I want to do a job and I need to make this board. I give it the board file, and then it will check the status, whether it's on the pick and place machine, either pick and place machine 1 or pick and place machine number 2. Or in my case, it can change depending on how you want to set it up. And then it'll light up. Well, on the screen, it has a button that you can press. It'll pull up the list of the components that are the feeders that have the components that you want that are on the storage rack. It will populate a list of buttons that you can click the button, and that'll light up the LED, and you'll know, oh, there's C0402 on 100NF. And you can just go grab the feeder, install it into the pick and place machine, go to the phone and go confirm that one's been pulled. And then you can go to the next one, and then the next, and then the next one. And the benefit there is I don't need to be trying to read anything. I don't need to be trying to scan QR codes or any of that. The inventory management system knows where the feeders are, whether they're on the rack or whether they're already on a feeder. And then I can deal with that really easy. When I add a new feeder with a new component, I have a bomb ingesting program that I'm working on, which will take the part name. It knows how to generate the part name that corresponds exactly with the part name that Openpnp will need. It will print off a QR code. I'm getting a continuous QR code or label printer instead of doing them on these stickers, because these stickers are expensive, crazy expensive, and they're really hard to get formatted right. So it'll print me off stickers. I'll stick them on the feeder, and then I'll go to the web server. I'll go add new part, and then I can, with my phone, scan the data matrix code, and it will send that to the web storage server, and it will add it to the system. It will light up where it wants that feeder stored. You store it. It knows the different widths. So it knows, like, this is a 24 millimeter feeder, so this takes 4 slots. So it literally will light up all those 4 slots with the first one indexed, and then it's stored. It knows that space is occupied, so it will help organize the system so that you don't have a bunch of open wasted slots too. Okay, that covers that. Now let's talk about feeder designs. This is something that's really also well out of my wheelhouse. So here is your standard bamboo feeder. And what I've managed to do is I've got a sprocket, I've got a gear train, and I got an N30 motor. Now, how are you indexing where the tape is? Well, I found a very interesting solution that I can use laser gates that let you index where everything is, so that it gets complicated. I'm looking at selling these so that, like, I'm making them for myself, but I'll gladly make them for other people. If you've got a Panda Placer machine and I get this whole system working, this might be something you really want. This is going to be as cost optimized as I can. I'm looking at either using a second motor, or I'm looking to use the same concepts that the Clever Feeder from Allen Designs does, where he has a bigger gear that uses the force of these sprocket holes. So it indexes into these sprocket holes. And when the tape goes forward, that also pulls the tape peeler mechanism, which then peels the tape. If I can do that, it might be cheaper than just another N20 or an N10 motor, which runs like $250. But it's going to be running on an RP2040. It has ADC for all 4 laser gates. There's a reason I have 4. It's so that I can do um, true precise indexing, and so that I can do half steps. So a normal full step is 4 millimeters. This gives me 2 millimeter steps. And I'm not just reading the whole, I'm reading the transition of the whole, which should give me a more precise and repeatable move. Um, I'm aiming for like 300 to 500 milliseconds per feed. Um, Alternatively, I'm also going to put a sensor here that will be a reflective sensor that should be able to read the nozzle. So it'll read a pick. It'll see the nozzle comes in, goes down, and then when it leaves, it knows it can feed forward. So the idea is I would like these to run in two configurations. One, independent, as in the feeder always keeps a component available. And then two, governed by Openpnp. So Openpnp would communicate to a USB device over with G code over, I think, just comms or serial. I think just comms. Um, that would then, that USB hub, or it's not really a hub, that USB connection would be an RP2040 that would then have a connection to all the um, backplanes. These backplanes are also RP2040s, so it's going to communicate I2C with a CS pin. So it can go backplane number 4, so it selects the CS plane for backplane number 4, and then it tells it what it wants it to do. Backplane number 4 then connects to up to 13 feeders through I2C and CS pins as well, which would be then this. So this would have another RP2040 with the 12-volt battery or power management, the ADC measuring for these and for this. And then it has motor current sensing for both the keeler and maybe for the drive motor. I don't know if it's going to be necessary for the drive motor. I'm using a high efficiency motor driver that can run both of these up to, I think, 24 volts, but I'm only supplying 12 volts. And that should cover most of the concepts. I'm in the process of designing the PCBs. So this is going to have aluminum PCBs that are 1 millimeter thick, just aluminum PCBs. The reason why is they're more rigid and they allow me to thread into them. So like my gears will be running on shoulder bolts with relatively precision ground centers, and then ideally a bearing. So everything will be bearing surface to shoulder bolt to aluminum PCB. Aluminum PCB on both sides, so it's a nice sandwich. And the width will follow true to the Panda Placer design or the bamboo feeder design of 12 millimeters wide for that 8 millimeter feeder. And then the wider ones, it's really easy to make sure that you match. That way it'll all fit in the storage system that I have designed, but also this is one of the most compact feeders that I can find. So like you'll notice I have some clipping issues here, but this is material that I can cut. Because this is the most compact design I could find, adapting this to a bigger feeder design, say for like the, what is it, SMTV3 from Bing, or the light placer in that. This should be really easy to redesign this gear, this, and this, move things around a little bit, and then everything should be fine. Once I get the core concepts of here's the feeder path, here's the peeling mechanism, this, and once I get the code, that's I think the most important thing for the laser gate, so that it's indexing everything correctly. There should be no backlash. Well, hold on. There can be as much backlash as you want. Because I'm indexing off of the tape, and I'm not indexing where the sprocket meets the tape by indexing the sprocket. There can be slop with the sprocket and the tape. I am indexing literally off of the tape. The components are as rigidly mounted as possible to the tape, that everything should line up and be as repeatable as possible, as opposed to having a encoder back here, which can't measure the slop here and the slop here and the slop here and then the slop here. Or if I was measuring off of this. I understand that this is overkill to some extent because the Bing feeders, which indexes off of slots here, works really well. But there is still the potential for slop. And indexing off of these holes requires these holes to be cut super precise. Whereas I'm indexing off of the tape. As long as I know that the tape is pushed to the left, to this wall here as much as possible, so it's indexed right, and it's going straight, then everything's repeatable. The holes should not change. If they are, then they're going to interfere with the sprocket anyway. So if you've got really damaged tape, garbage in, garbage out. But this should give you the most direct measurement you possibly can without using just the camera and indexing off the sprockets. Now, the only pitfall is clear tapes. But because these are ADC, I'm hoping that the reflectiveness of the clear tape will diminish the laser enough that I can sense it. And then if I can sense that diminished amount, I can have a mode that is meant to sense the plastic tape, the clear tape. If not, then I may look into like having a little, was thinking about it. If I had a little sponge here that had black ink on it that colored the tape, then it would solve all the problems. Or something else. And then if I can't use clear tape, I can't use clear tape. At that point, then maybe having the sprocket indexing is the better solution. But I think I'll be able to index off of that. So that's sort of the whole ecosystem. I want these feeders. Yes, this one. These feeders, because I'm already built into this ecosystem, but the design for the feeder will be adjustable for other feeders. So if there's a large demand, I can reconfigure this and then make them for you. I'm quite possibly going to just be releasing the files. I haven't decided on that yet. These feeders will then interact with my inventory management system, which will have data codes, data matrix codes that tell you what component is on this. So you no longer is the time of printing out or making sticky notes that say this component and this component and this component is on the job. And then I have to go find the components and then either put them on feeders, which is annoying as all heck, or pulling them off of a rack. The system will just light up, lead me to the things that I need, light me to the things that I need. I'll store them on the pick and place machine, which then can use OCR and the camera to go through and scan all the feeder banks. Excuse me. Hold on one second. Once it scans all the feeder banks, it will populate them with the part name that's listed on the QR code into the correct slots, because it will know that the QR code should be at this range. And I have the script already where I can be like, select feeders, any number of feeders within a feeder bank. So like 4 in feeder bank 1. And then it will pull up the coordinate data for each of those feeders, and along with that coordinate data, where the QR scanning code location is. Then that's the whole like loading the pick and place and unloading the pick and place process as automated as I can make it. I'm not going to have some fancy robot pulling feeders and putting them back. But it also then ties into my program with the LCSC footprint importing. That's the only thing I have done. It should be done. I'm not noticing a whole lot of problems. I need to keep running it through more boards. Problem is I only design boards so fast. So what I'm doing is I'm deleting the whole parts library, which is terrifying. I have it backed up on on both of my pick and place machines, and I'm rebuilding that library using this tool. You still have to like calibrate vision for each part, so you still need to have it pick up a part, go over and calibrate it, make sure it's lining everything up right. But this takes so much of the manual, tedious time wasting and makes it as quick as possible. That covers my whole crazy system. If you'd like to help, I'd love help. You can reach out to me. Like if you're a mechanical or an electrical engineer and you're like, hey, stupid, you're doing this stupid. There's a better way to do this, or you shouldn't be doing this. If you have an idea on how to solve some of the concerns I have with the laser gates, get a hold of me. I'm happy to talk. My plan is, I'm a big believer in the open source community, but this is also taking my time. And while I benefit from it because I get the things, I would also like to offer these. So like for the inventory management things, I'll print the parts for you, but you could also just download the parts and print them yourself. For like the PCBs, if you'd like the PCBs, I'm planning on releasing the PCBs once I have the system complete so that I have it all documented, and then you can go from there. But at the same time, I will sell them on my store as like extras that I make and then that you can use or buy and use. I think that covers everything. I've ranted for 41 minutes. If there's even one person that stayed long enough to listen to me rant for 41 minutes, you are a very kind person. Or I'm just noise in the background, at which I'm fine being noise in the background. You have a wonderful day. Don't work too hard. And this is Marshall at Scree Custom Keyboards and Scree LLC signing out. Bye.